Okay, let's look at problem 36 from the homework. So it says an inline skater accelerates from 0 meters per second, there's our starting velocity, to 5 meters per second, there's our final velocity, in 4.5 seconds. So we have time, then continues at this constant speed, constant velocity, for another 4.5 seconds. So these are two different times. What is the total distance traveled by the inline skater? This looks like we're going to have to do two equations to get the total distance because they start out accelerating for 4.5 seconds, then they move at a constant speed for 4.5 seconds. So we need two equations to solve for distance. We'll solve for the distance in the first part of the problem here. We'll get the displacement there. And then this is the part that accelerates. And then for the constant velocity, we'll get the distance there. So we're going to use two different equations, then we're going to add them up. So we're going to identify our givens again. So I'm going to do this in two parts. So part for the acceleration portion, we've got a VF equals 5 meters per second. We got a VI equals 0 meters per second. That's where it starts. And then we got a time of 4.5 seconds. It doesn't tell us acceleration, but we can figure it out from our information here. Then we can plug that into another equation to get distance. So for the part with constant speed, we have, assuming we're going to continue from the first part, this final velocity is the constant velocity here. So v equals 5.0 meters per second, and t is another 4.5 seconds. All right. And di will be whatever the distance is that we calculate from the first part. All right, so the unknown is the total displacement. That's what we're going to try to figure out. Equations. We're going to use multiple equations here. And for the first part, first we need to figure out acceleration. Well, based on the information given, use this kinematic equation. Vf equals at plus vi. And if we just rearrange this one a little bit, we can get acceleration. So if we want to get acceleration, we will move vi to the other side of the equation by subtracting it. Because it's being added, we will subtract it. Okay. Then you have Vf minus VI equals AT. Then to get A by itself, well, it's being multiplied by T. So the opposite of that is division. So we'll divide by T. Do the same thing on the other side of the equation. Then T cancels, and then there we go. That's our new equation. VF minus VI divided by T equals A. And you may have just remembered that's what acceleration is. So I'll rewrite that. Minus VI divide by T equals A. All right. That'll get us the acceleration. Then to figure out how far it went, we will use this equation where df equals di plus vit plus half at squared. Now that we have a. And we just want to know how far it went. Well, df minus di is displacement. So if you move di to the other side of the equation, you could just simplify it to displacement equals VIT plus half AT squared and if you want it, you could simplify it even further because VI is 0. Therefore, the VIT part of this doesn't matter because 0 times anything is 0. So really, it's just half AT squared. And that'll get us the first distance. Why don't we just go ahead and solve that for now, and then we'll go back and solve for the additional distance when the car is going the same, or I'm sorry, the skater is going the same speed the whole time. So to solve that, just do 1/2 of, I'll just plug this right in there, VF minus VI divided by T, because that will be acceleration. And VF is 5 minus 0 divided by 4.5 seconds times 4.5 squared. And that equals, sorry, that equals 11.25 meters. We're not going to do any sig figs yet because we're still in the middle of this. So now we're going to figure out how far the skater goes when they're going a constant velocity. All right. So we look up here for the second part, they're going at constant velocity for 5 meters per second for 4.5 seconds. And now we know the DI is 11.25 meters. Not rounding yet until we get to the final part of this problem. All right, so we'll use that as our DI. Well, The equation we will use for that is d final distance equals initial distance or initial position plus vt, or vt plus di might be the way you wrote it in your notes. So no need to do algebra here, we'll just plug and solve. So 11.25 plus 5 meters per second times 4.5 seconds. And our final answer will be it will be about 33.75. Let's look at significant figures. Got to go all the way back to the problem. Well, this right here that has 1, 2 significant figures because that decimal. I'm going to count all the zeros. This has 1, 2. This has 1, 2. And so does this. So our final answer should have 2 significant figures. So our final answer will be 34 meters.